Okay, we have started today's class. We'll continue from what we are doing in last class. So if something into D এর basic concept হচ্ছে whenever the force is working at an angle with the object's axis, other than finding out the perpendicular distance, we can find out the perpendicular component of the force that is aligned with the object. For example, if this is your F and the object and the force makes theta with the object's axis, where the distance given is d right over here. So if f is like this, then we can divide up the f in two perpendicular components, f cos theta along the axis of the object and f sin theta along the perpendicular side of the axis of the object. The moment of this force about this pivot point is 0 because this force is going through the pivot point, where this force, this component being perfectly perpendicular with D, the moment can be written as the F sin theta into D. And that's basically it.
Sir, can we consider that the F not being perpendicular will not give us the desired output by the regular formula? So we use F sin theta to at least imagine what it would be in
No, we're not imagining the
perpendicular.
value. We are actually dividing the applied force F into two perpendicular components for the sake of easier calculation. One component of the force, which goes directly through the pivot point, produces zero moment, and the other component, which is F sin theta, produces an actual moment. The advantage of doing the math in this way is the drawing becomes much too simpler for the figure. We don't have to draw the whole right angle triangle for d sin theta and such. Dividing the force itself can help us solve the problem in a much too simpler process. আচ্ছা, এটা ছিল একটা জিনিস। আপট্রাস্টের পার্টটা একটু দেখাই। তোমাদের সিলেবাসে এই চ্যাপ্টার 3 তে আপট্রাস্ট রিলেটেড কিছু প্রবলেম আছে, যেটা প্রপার্টিজ অফ ম্যাটেরিয়ালের চ্যাপ্টারটাকে রিপ্লেস করছে। সো উই ডোন্ট হ্যাভ দোজ properties of material in your syllabus anymore. For example, what is the atomic level structure for brittle substances, polymeric substances, amorphous substances? So we don't have those. So let me just show you what upthrust is.
স্যার আপট্রাস্টিক কি আমাদের মানে বুকলেটে নাই স্যার?
না মনে হয়।
So sir, shall we start copying, sir?
You can.
স্যার একটু স্ক্রল আপ করতে পারবেন?
এইটুকু পর্যন্ত বোঝা যাচ্ছে কিনা দেখো। Let me just go by the writing part by part. এটা তোমাদের একটু লিখে নিতে হবে কারণ এটা সম্ভবত তোমাদের ক্লাস নোটে নাই, as far as I remember এটা তোমাদের ক্লাস নোটে নাই। Upthrust is defined as the upward force of an object applied from within the liquid. Actually it can be a fluid, it can be a gas, which in which manner air also applies a certain upthrust on a certain object. This is why multiple other objects which has a lower density than the average density of air can actually start to float upwards. For example, a gas balloon, helium gas balloon, it can start to go upwards within still air is because of upthrust. The idea is very simple, is that whenever we place an object within a fluid, the object occupies a certain volume of its own. Due to the gravitational force that applies on all over the fluid, try to understand. Let's say we have some water body over here, and gravitational pull is working on this entire part of the water body. So all the liquid water is trying to go down as much down as possible. So they have a downward force onto them because of the property of weight. Upthrust is a force that is only applicable whenever your fluid body, the whole system, is under a uniform gravitational field. For example, like on top of the earth. So the gravitational field on top of earth's surface is all working inward radially towards the center of the earth. And that's why, because of that gravitational pull working downwards, we experience the upthrust from onto different objects. So the way I define this thing over here, have a look over here. Upthrust is the upward force on an object applied from the fluid because of the volume or space occupied by the object within the fluid. This is one way to put it. Value of upthrust is equal to the weight of the displaced fluid and works upwards on the object. This is an important part. Upthrust of an object on an object will always work upwards. Weight always works downwards, and upthrust will always work upwards, irrespective of the object's position, orientation, alignment, whatsoever. So one other one, থাক এই পাশে হাত দিয়ে ঠিক করতে হবে। আচ্ছা, sorry, never mind. So one important thing that goes for the upthrust is that whatever the value, upthrust should always be aiming upwards. Weight is working downwards, upthrust will always work downwards. Upthrust exists due to the pressure difference between the top and bottom surface of the submerged object and can be easily calculated by pressure difference into cross-sectional area. This is the basic concept for the upthrust idea. So then I went for some mathematical derivation, which we know this formula: pressure under h depth of a fluid is given by P equals to h rho g, where rho is the density of the fluid. So simple example, let's say we have a body of water. So this is actually a continued figure. So we have some air on top. This is the surface where the air and water are separated. So water is up to this much level. Below this level, we have all water. And I label two different points over here, A and B. Let's say point A is a depth of HA from the surface of the water. Point B has a depth of HB from the surface of the water. So I wrote the two individual pressure values. Pressure due to water at location A is equal to HA rho WG. Pressure due to water at location B is equal to HB rho WG. So these are just two different pressure formulas. So total pressure location at A, I have shown you this part to understand that, to make sense with you, that the total pressure that will be experienced at that location would not be exclusively due to the liquid or water. The air is also continuously pressing onto the top surface. So if you're trying to calculate the total pressure at location A, this should be the liquid pressure plus atmospheric pressure. So that's what comes up over here. So total pressure at location A should be given by liquid pressure plus atmospheric pressure. So this is the absolute pressure or the total pressure, combined pressure. We can use a lot of different terminologies, but meaning that this is the altogether pressure of this location if you are trying to calculate this out. So HA rho W, W in this case represent the density of water. That's why I'm using rho W into G plus pressure of air. And similarly, total pressure at location B should be given by the same expression. We add these two numbers together. This is just a representation for the pressure calculation. For the next part, I'm going to show you how to do the calculation for pressure. Over here, I have a sort of a not drawn to scale, but somewhat attempted to be drawn to scale type of a figure. What I'm trying to show you in this figure is that if we have some water over here and we have a cylindrical solid object over here, which has a radius of r and a height of h, and is now currently placed vertically within the liquid body, water body, what you should understand that at the top surface the pressure would be less, at the lower surface the pressure would be more because of the height difference. And as we slowly, if you measure the localized pressure at individual different level of the objects along its length, we should see that as you slowly go downwards, the pressure is going to slowly start to go higher. So what I have tried to represent the top surface pressure with smaller length arrows, the bottom surface arrows pressure to be longer sized arrows, and gradually on the sides, the arrow sizes are slowly becoming larger. Have a look, these red arrows are slowly becoming larger, representing a bigger value of pressure. Now the horizontal pressures should perfectly balance out each other because they would be equal on all directions. So we don't have to calculate for that, which essentially goes on to mean that the object is not going to experience a horizontal resultant force for any for its density property or for the weight property of the liquid. However, the force experienced in the vertical orientation would be somewhat different because the amount of force that this surface experience, which would be calculated by pressure at the top multiplied by cross-sectional area over here, is somewhat smaller compared to the force experience on the lower surface. I might as well draw this surface with a dotted line, maybe like this. So the force experience on the lower surface would be significantly bigger by pressure into area compared to the force on the top. So that difference is basically what gives rise to the component that we are discussing today, named upthrust. So here comes the mathematical derivation. I'm going to zoom out a little bit so that you can see the figure and calculation at the same time. Upthrust is given by the weight of the displaced liquid, which I'm writing as ml into g, L liquid, and this mass of the liquid will be can be calculated by the density of the liquid multiplied by the volume of the object. Now I have written VB. What did I write B? Volume of the body, volume of the solid object. I could have actually written volume of the cylinder. Achha, might as well replace the symbol a little bit. I did not mean it to be. By B, I actually meant that volume of the object. Yeah. So the mass of the liquid body or the mass of the water that has been displaced can be calculated by the density of the water multiplied by how much volume of water was moved out. So we are simply multiplying those two numbers. Now you might wonder that why the mass of liquid is calculated by the volume of the object, because the idea is very simple. The volume of the object and the volume of the displaced water, they are both equal. So that's basically the idea that I tried to give you over here in mathematical term. Because this is a cylindrical object, we could write this as pi r square h. Easier to work with for a formula for a cylindrical object. We could also do this for a cuboid object as well, but it's gonna be slightly different if we have curved surfaces, for example, like a sphere, or maybe like a bullet shaped object. If we have that kind of a curved surface, the calculation gonna be a bit difficult. For simplicity's sake, we are not showing that calculation for at your level, and you would not be bothered by those shapes in your level at your level as well, so you can disregard that factor. So the way the equation goes forward, that upthrust is given by the weight of the displaced liquid, mass of the liquid into gravitational force, density of water into volume of object into g. So density of water is placed over here, pi r square h is written over here. In this line, I just took out the pi r square out and put the density of water in, and I wrote this part over here in the shape of h rho g to make it pressure. Now what you should see over here, that I have written h rho g as delta p over here. I didn't write it to be exactly p because in this case h is representing the height between the height of the cylindrical object, which is basically the difference between the top level depth and the bottom level depth. In other words, although I haven't showed it to you, I could, if I try to label this thing over here, let's say with two different variables. Let's say if this depth is labeled as height of the top surface, and if this level is labeled as the height of the bottom surface, if you do the difference of these two, height of the bottom minus height of the top, you basically get h. So, and because that that height difference is basically the h, so that's why the h rho g for that relevant height also gives us the pressure difference delta p. So we wrote delta p over here, and delta p can be also written as pb minus pt. I specifically wrote the bigger value at the beginning so that you do not get a negative force. But you should understand that in this case the force should be directed upwards because the pressure is bigger at the bottom, pressure is smaller at the top. So that whole expression can be written in words like that. We can also rewrite this as area multiplied by pressure difference, which is the basic formula for the upthrust. That's pretty much it there for the theoretical value, but the calculation of this kind of questions can reach a further relevant required mathematics depending upon each individual question. There are certain questions where we need to get beyond the scope of this formula derivation and be able to solve problems for a bit more detailed scenarios. uh, there is a certain question about I think the average density or average density of air. There's a certain question which I find it very difficult to solve every single time. I need to look up. I'm ভুলে গেছি কোশ্চেনটা কোন ইয়ারে ছিল, but it always shows up somewhere and it's a difficult question. But anyway, এই পার্টটুকুর কনসেপ্টটুকু বুঝা গেছে কিনা পোলাপান?
Yes, sir.
Yes, sir.
স্যার
হ্যাঁ বলো।
আপথ্রাস্ট কি সবসময় কনস্ট্যান্ট থাকবে? কারণ ভলিউম তো, যে ভলিউমটা ডিসপ্লেস হচ্ছে এটা তো কনস্ট্যান্টই থাকতেছে।
But sir, height কি চেঞ্জ হলে স্যার আপথ্রাস্ট চেঞ্জ হতে পারে স্যার?
একটা certain objecটের upthrust, as long as the object is kept without hollow, if you don't make it into hollow object, if we keep the object with a solid volume, typically the upthrust does not change. The reason upthrust does not change because irrespective of the orientation of the object, the weight of the displaced liquid, which is basically the mass of the liquid mass of the liquid, which is density of water into volume of the object multiplied by g. So if you try to understand that, this is one expression for the value of the upthrust. If we rotate this object, this expression will not become different. So density of water would remain the same and the volume of the object would also remain same. Even if we, let's say, if we have this same solid object, we make it go through some physical deformation process and we reform the object into some other shape. For example, we make it into a maybe cuboid or like a cake or like a flat slab kind of shape, but still at the same temperature, the volume of the object would still remain the same, which means the magnitude of the upthrust value, irrespective of orientation or shape, should remain the same. If you wonder why should that work, the idea is pretty simple. Let me just give it to you in this manner. Let's say if we have a cuboid object, let's say that looks like this. Why am I so bad at drawing a cuboid? Okay, I can work with that. Okay, can you see a cuboid object over here? A three-dimensional cuboid
Yes,
object.
sir.
Okay, so একটা জিনিস হচ্ছে, মনে করো এটা হচ্ছে দেখতে পারফেক্টলি কিউবের মতো হয়েছে, আর মনে করো এটা পারফেক্টলি কিউব না, মনে করো আমাদের লেংথটা বেশি। So can I make this object go longer? I don't think that's possible. Is that possible?
Kind of, I guess, sir.
It's not possible.
Sir, if you can drag it to a farther side and then drag the line, extend the lines, it is possible.
I'll do what I have to do. The age-old method of doing stuffs. Boom. Put it into paint.
So why can we move objects more easily when they are in fluid, like water উপর heavy object are easily move করতে পারি?
বলতেছে okay. Works for me. Can I select this object individually? No, I cannot, because this image is too large. So might as well make this image smaller. Let's see. Okay, got it. So that's the point that I was trying to make, is that if we have the object that has a slightly different dimension, let's say in this case I am trying to show you that for an object which has a longer height and smaller surface. So what's going to happen whenever this object, if this object, for example, for this orientation, the upthrust should be calculated by the pressure that works across this surface and the bottom surface, and the relevant height for the difference in the pressure would be the side length. So you're gonna come across some number. The way this whole math is gonna work out, if we tilt the rotation or tilt the orientation of the object, let's say if we place the object in this orientation, let's say, yeah, in this orientation, then you're gonna have a significant rise in your volume, in your cross-sectional area, and you're gonna have a proportional decrease in your height. So your delta H is going to become smaller, but your the cross-sectional area through which the pressure is capable to work, that is going to become larger. So the combined effect is going to be compensated equally. So you're going to have the same amount of upthrust, provided the object is still a solid object. But that would not be the case if we make this into a hollow object, for example, like a submarine. If we use the same amount of material and then make it into a hollow tube or a hollow cylinder in which we actually are going to place in some air, then the whole math is going to work out differently, because in that case, the combined density of the whole object is going to be different than the density of the actual object. Because if we convert this whole thing into a hollow object, for example, let's just like a cylinder, like a submarine. Let's say if I draw up a hollow cylinder, let's say this is a hollow cylinder, and let's say the two faces are closed off by two sheet metals as well. So you have some empty space inside the hollow cylinder. Let's say this is the empty space. This empty space is filled up with air. Now, important part that the density of this whole object is not equal to the density of the metal that by which it is made up from. Because if you are trying to measure the density of this whole object, that would be the total volume of the whole thing, which is basically the volume of the air inside plus volume of the metal itself, volume of the metal. This is the total air volume of the whole thing. That total volume, if you divide the total mass of the metal, because air mass is actually very negligible compared to the metal mass, that is going to give you the total new density of the whole thing. So if you have locked up a huge amount of air inside, you're going to have a much lower density. That's basically how ships actually are made, because they use the hollow shape structure, so that at one point the combined density of the whole object, including the metal part and also the within volume air part, that density can be lowered, which can give us a significantly bigger amount of upthrust for the same amount of material because of the shape difference. I'm not sure if I answered your question, Abdullah. Did you get your answer of your question?
Yes, sir.
আচ্ছা, বুঝা গেছে?
Yes, sir.
Beautiful. ইসুফ কিছু একটা বলতেছিল মনে হয়, মাঝখানে খেয়াল করি নাই।
Sorry, if the orientations are changed, then also the upthrust will be changed.
No, orientation will not affect the magnitude of the upthrust, because because the two mathematical components, which are the pressure difference and area, they will work around each other in such a proportion that their product value would also remain the same, irrespective of the orientation.
But sir, at that time, the height may also change and the cross-section area may be increased.
Exactly, and there one of the variables decrease and and the other variables increase is going to be compensate for each other perfectly.
And another thing, sir.
Mhm.
Over here, we are considering that we have sunk this empty cylinder into water. So the reason why the upthrust decreases is big. Okay, I'm not able to get this part. So
maybe I'll rephrase your question. Maybe you're having a difficulty making the question. Maybe you're trying to ask me that if this is the whole case of the cylinder's density, then how does it say the submarine goes underwater? Is that your question?
I mean, no, sir. I mean, if we're only considering oh no, okay, sir. Basically, we are taking in factors of volume and mass, which is okay. That's the entire. Oh no, sir, no, sir.
It's fine. If it's understood, well then good. So পোলাপান এটুকু তোমরা একটু লিখে নাও, অথবা হচ্ছে যদি লিখতে না চাও তাহলে আমি একটা কাজ করতে পারি, I can make an image out of it and I can give it to you in an image format. I think this much image can be.
Sir, you can even turn it into PDF format.
আচ্ছা, কপি করে ফেললে ভালো, well and good. যারা ক্লাস জয়েন করে নাই বা পরে জয়েন করছে, especially more for me, so that I could skip writing this thing in upcoming chapters. I'm gonna save this part. Rajini কেমনে save করে? Export high quality image. Okay, I'm gonna write this
Upthrust.
9702. Upthrust. Did it get saved? Yay, it did get saved. So this is one of the failure. This is one of the image that is .svg. It's sort of a high quality image. Can be only opened by browsers for reasons that is not understandable for me. Anyway, I'm gonna share this this one to all of you in the messenger group.
Sir, it is also capable of opening with PDF readers like Adobe Reader, but the quality diminishes.
আচ্ছা, হতে পারে। Why isn't the drag option not working? I have no idea. That's your file. এক মিনিট বলবো না, আমি তোমাদের জিনিসটা দিয়ে নেই, তারপরে হচ্ছে আমি পরের টপিক এখনই আলাপ করা শুরু করতেছি। Give me a bit of a time. You can't file edge. এই এসভিজি ফাইলগুলো আপলোড করতে গেলেই এই টাইপের ঝামেলা করে। বলুন, দেখো তো এটা গেছে কিনা আদত। তোমরা কেউ কি পাইছো এটা?
না স্যার।
এটা কি কোনোভাবে এমএস পেইন্ট ওপেন করা সম্ভব?
So you can resave the thing and as PNG again.
না, পিএনজি তে সেভ করলে কোয়ালিটি কমে যায়। কোয়ালিটি কমে যায় মানে হচ্ছে the whole thing becomes blurred.
সেখানে জুম করে দুইটা সময় নিতে পারেন।
স্যার
Sir, you can just rename it and just change SVG to PDF, I think, in case if that works. Not sure.
স্ক্রিন ক্যাপচার করতে পারেন এই যে উইন্ডো এস আর শিফট একসাথে টিপ দিয়ে।
I mean the snipping tool. Yes, you can do that also. Okay, so I'm also not sure about the PDF part.
Okay, how about now? We just rename this thing into JPG. Okay, so if I try to share this thing, which has an extension of JPG, that should work, right? Like attach a photo or video, Messenger Labs, normal photos. Should that work? There's a problem with the image file. Good. I don't know how can I share this thing. Should I make a zip file? Zip file to Messenger save করা যায় না। আচ্ছা, ঠিক আছে।
স্ক্রিনশট নিয়ে রাখতে পারেন।
হ্যাঁ,
স্ক্রিনশট নিয়ে রাখতে পারেন স্যার, একটু জুম করে, ওইটাতে কোয়ালিটি ডিক্রিজ করে না।
মানে স্ক্রিনশট নিয়ে স্যার তারপরে একটু ক্রপ টপ করে করতে পারেন স্যার।
জি, স্ক্রিনশটে তো আছে এইটুক। মনে করো এখন পুরা লেখাটা হচ্ছে মনে করো হচ্ছে এইটুক সাইজের, ঠিক আছে। আর আমি যদি এটা স্ক্রিনশট নেই, এই লেখাগুলো আসবে এই কোয়ালিটিতে, মনে করেন এখন জুম
না স্যার, আপনি জুম করে 4টার মতো স্ক্রিনশট নেন তাহলে তো স্যার হয়ে
ও
যাবে।
আচ্ছা, ও yeah,
I don't know in
what-
my
what-
end why the SVG or the image files isn't coming yet.
SVG vector image
বুঝি নাই।
তাই চল SVG হচ্ছে vector image তাই চলে না আর কি।
Well, if
Vector image না।
Microsoft Whiteboard allows you to save it in that format, why is it not shareable on an internet platform?
I mean, it's actually shareable by means of Google Classroom, sir. Like one of our teachers did that.
ইমেইলে তো সবকিছু শেয়ার করা যায় ইমেইলে।
Sir, Google Classroom, sir.
আচ্ছা, গুগল ক্লাসরুম ইজ স্টিল আউট অফ মাই বাউন্ডস, আমি এখনো গুগল ক্লাসরুম শিখি নাই, সো বলতে পারতেছি না।
স্যার আপনি না বলতেন তুলান স্যারের কাছে শিখে ফেলছেন।
I planned, then I am a good procrastinator. Not that uh, I I condone that. I mean, I don't like that, but I am that. Print screen তো দিলাম।
স্যার আপনার ওয়াইফাই কোনো সমস্যা আছে স্যার? এই কারণে হয়তো হতে পারছে না স্যার। যে ফর এক্সাম্পল এখানে কোনো টিক আসছে না স্যার মেসেঞ্জার ওখানে আপনি যে পাঠিয়েছেন। দ্যাট মে বি দ্য রিজন স্যার।
No, Messenger doesn't want me to share this stuff.
Sir, what if you just Google it, how to share SVG in Messenger?
বাহ,
Sir, like I said, it is Messenger is not hampering the not a real state.
স্যার আপনি
Just
ক্লাসের
messages
পরে
টা-
ট্রাই
Obvious
করে
sir, কথা যে লিখছিলেন এগুলো সব আসছে।
এটা এসভিজি এর ফরম্যাট করা আছে, আমি ক্লাস শেষ করি, ক্লাস শেষ করার পরে এটা আমি হাবিজাবি করে তোমাদের পাঠানোর ব্যবস্থা করব। হ্যাঁ, এটাই ভালো হয়, এখন এটা নিয়ে মাথা খারাপ করে লাভ নাই, সো ডিসরিগার্ড দ্যাট ফ্যাক্ট। মুভিং অন, এটা একটা দরকারি জিনিস ছিল, এটার উপর বেস করে কিছু এমসিকিউ আছে, যে এমসিকিউ গুলো অ্যাকচুয়ালি ক্যান প্রুভ টু বি কোয়াইট ইন্টারেস্টিং। যেমন এয়ার ডেনসিটির একটা এমসিকিউ আছে, আমি ভুলে গেছি এটা কোন ইয়ারে, ওই এমসিকিউটা অনেক ভালো, মানে গুড থট ক্যান্ডি। I think S17 না S18 এর মনে হয়, দাঁড়াও। আচ্ছা, তোমাদের আরো ফার্দার কোনো কোশ্চেন থাকলে আমাকে বলো, আর নাহলে ওয়ার্কশিট প্রবলেম দেখানো শুরু করি।
স্যার একটা লাস্ট ক্লাস থেকে একটা কোশ্চেন ছিল স্যার। স্যার
স্যার
যে প্রেসারের উপর বেস করে বা ডেনসিটি রিলেটেড কোশ্চেনের উপর এই ধরনের কোশ্চেন আছে। কোশ্চেন নাম্বার 13টা দেখো। সো এই টাইপের কোশ্চেন টিপিক্যালি হয়। Liquids X and Y are stored in large open tanks. Liquid X has a density of 800 kg per meter cube. Y has a density of 200 kg per meter cube. At which depths are the pressures equal? So H rho G, H rho G. You just have to equate those, and I mean, হ্যাঁ আব্দুল্লাহ কি যেন বলতেছিলা?
I have a problem, স্যার। প্রবলেমটা ছবি পাঠাতে পারবো গ্রুপে?
হ্যাঁ
আপনি
গ্রুপে পাঠাও, আমাকে পাঠাও, পাঠালে হবে, সমস্যা নেই।
স্যার পাঠিয়েছি।
দেখতেছি। সো এই টাইপের কোশ্চেন গুলো আসে, এই টাইপের কোশ্চেন গুলো অ্যাকচুয়ালি করা খুব ইজি। You just develop the two equations. The question is asking at which depth the pressure should be equal. So pressure of X equals to pressure of Y. So Hx into rho X into G should be equals to Hy into rho Y into G. G আর G বাদ। So what you ultimately get that hx by hy, this should be equals to rho y by rho x. এখানে লিকুইড y এর ডেন্সিটি হচ্ছে 1200 liquid x এর density হচ্ছে 800. So we place these two numbers over here, we're gonna get 3/2. So this basically goes on to show যে আমাদের hx আর hy ratio 3/2 হইতে হবে। So hx এর ভ্যালু হইতে হবে বড়। So try for all of these options, for which one or one of these you get 3/2 ratio. I think
The C.
C is the correct response essentially. Easy to do math provided you know how to approach the problems. আচ্ছা দেখি কি প্রবলেমটা পাঠাইছো।
The number 3 টা MCQ.
হ্যাঁ দেখতেছি। Metal drum is held 300 meter beneath the surface of the sea by a vertical cable as shown in figure 4.16. Okay, we have the water surface 300 meter, we have a cable. Acha. The drum has a volume of 0.500 meter cube and a weight of 800 Newton. The density of the seawater is 1030 kg by meter cube. What is the tension in the cable? আচ্ছা এবার আমরা কিভাবে করবা তাই তো?
Yes, sir.
That's it. Okay. So let's have a look. This is 4.16. There is this is the seabed, as this part over shows over here. This is a seabed. Here it is written seabed. So here is a seabed. At the seabed there is a cable. This cable is connected to the drum over here, and apparently the drum is floating, or it is trying to go upwards, but the cable is holding it at its place. Resonant force on the drum would be 0, because the question says that metal drum is held. Held in this case would mean a stationary constant state, or the resonant force should be 0. So a metal drum is held at 300 meter beneath the surface of the sea by a vertical cable. This motion of weight of the dimension of the drum is not given, right? আচ্ছা dimension of the dimension actually লাগবে না কারণ হচ্ছে actually we have the volume of this thing and we have the density of the seawater. So in this case resultant force should be 0. So এখানে আমাদের sum of upward forces should become sum of downward forces. So upward forces গুলো হচ্ছে কি upward force minus weight plus tension should be equals to 0. So weight working downwards করবে, cable downwards আসবে। So আমাদের upthrust calculate করা দরকার। Upthrust should be equals to weight of the
rho g volume না
weight of the seawater তো ওইটা দিয়ে করে ফেলি। সেটা হবে হচ্ছে আমার density of seawater into volume of the object, volume of the box or the drum multiplied by g. So 1030 into 0.5 into 9.81. এটা কত দিবে দেখো, ক্যালকুলেটর কই আমার, পাইছি 030 into 0.5 into 9.81, 5052.15. তো তার মানে এখানে যদি লিখি 5052.15 minus 800 plus tension equals to 0. এখান থেকে দেখো টেনশনের ভ্যালু কত আসে।
4.4 আচ্ছা 4252.15
তার মানে about 4.3 kilonewton if you round it up to 2SF.
yes sir বুঝছি স্যার
Is the correct response. এখানে আমাদের অ্যাকচুয়ালি যে জিনিসটা একটু আগে দেখাইলাম যে হয়ে গেল হোয়াইট বোর্ডে আছে, হ্যাঁ, যে জিনিসটা একটু আগে তোমাদের দেখালাম যে আমরা কিভাবে হাউ ক্যান উই ক্যালকুলেট দ্য ম্যাগনিটিউড অর দ্য value of the upthrust. It can be it is dependent upon, it can be approached by two different calculation methods. So one can be done directly by the density of the liquid into the volume of the object into G. This is a direct formula for that. Or in cases where the two different height variations for the object is given for a certain orientation of the object, it can be also calculated by the cross-sectional area into the pressure difference of the two heights. So এটা দিয়েও করা যাবে। এখন এই ম্যাথের জন্য আমাদের এটা অ্যাপ্লিকেবল হয়েছে কারণ অবজেক্টের ডাইমেনশন দেওয়া ছিল না, ফুল অবজেক্টের ভলিউমে দেওয়া ছিল, সো আমাদের এটা নিয়ে বদার করতে হয় নাই। সো দ্যাট ওয়ার্কড আউট। আচ্ছা, ওয়ার্কশিটে কিছু প্রবলেম
এখন কি
দেখো?
ওয়ার্কশিট
হ্যাঁ হ্যাঁ, ওয়ার্কশিট
yes sir sir I have some problem
বলো।
sir number 3 মানে 3.1
ফোর্সেস এর মোমেন্ট ওয়ার্কশিটে
yes sir
Very
মানে 3.1 number 3
হ্যাঁ, নাম্বার 3 এটা ভালো কোশ্চেন দেখাচ্ছি। So we're starting the MCQ solution for the force and moment worksheet. We'll go by part. So for those who have attempted some problem, please share your problem list. If you haven't, keep your eyes peeled, your ears open, and ask me questions if you have any. Yep. Okay, let's have a look at this question. Two blocks X and Y of masses M and 3M respectively are accelerated along a smooth horizontal surface by a force F applied to block X as shown. What is the magnitude of force exerted by block X on block Y during this acceleration? আচ্ছা, এটা কিভাবে কাজ করতে হয় সেই জিনিসটা আমরা একটু বোঝার চেষ্টা করি। One of the first thing that you need to understand that this block has a mass of M, this has a mass of 3M. Whenever we'll apply this F force on this side of block X, and because they're touching into each other, by the application of this force, both of this combined mass X plus Y, they would move forward at the same rate with the same velocity and same acceleration as well, which means now the combined 4M mass would be experiencing the total applied force F and will have the same acceleration. This is the important part, that both of the objects would have the same acceleration. So if I try to write this out, for example, let's say F equals to ma, so the acceleration of the object should be given by F divided by, in this case the mass is actually M plus 3M, so this is F divided by 4M. Just a second. So the common acceleration for both the objects X or Y would be given by this much number. Now, this is the part that you need to understand. How much force would X require for its own acceleration? So what would be the requirement of the force X? Force required by the X to maintain that acceleration would be mass of the object X multiplied by acceleration of the X. Acceleration is exactly same. So in this case, mass of the object X is actually M as per the question, and acceleration of the object is gonna be F divided by 4M, which basically gives you F by 4. Try to understand the significance of this calculation. What this actually means, to maintain this magnitude of acceleration for object X, it is only gonna require this much force, but it was being pushed by this much force. So where is the rest of the force is going by? The rest of the force is actually transferred to this larger object, which is gonna use it for its own acceleration. How? We can pretty much show it by subtraction, or we can show it by multiplication as well. If we simply go by subtraction, that Fy would be given by F minus Fx. That basically gives you 3F by 4. That's one way. Or I could directly go for Fy equals to mass of y into acceleration of the y. In this case, mass of y was 3m multiplied by F divided by 4m. So ultimately m and m crosses out, you get 3F by 4. This means to maintain this value of acceleration, object y requires this much force. Where would this force come from? Object x will push object y by this much force. Here's the deal. We are applying a force on the left side of the object x. Out of this F force, object x uses an amount of F over 4 force for its own self. It uses that for its own self, and it transfers the remaining force onto object y, which is 3F by 4. So at this contact surface between x and y, the force that works between the two objects x and y is 3F by 4. Object x pushes object y by 3F by 4 force, which is by obviously the forward force for an object y, and by Newton's third law, object y also pushes the object x back to the same amount of force. So the resultant force on the object x would be equal to F by 4, because if I want to draw the exclusive figure for object x, this would be look like this: F force from this side and 3F by 4 for force from this side. So the resultant would be F by 4 working to the right. This for object x. As for object y, the resultant force is only towards right, 3F by 4. That's it. বুঝা গেছে কি?
Yes, sir.
কোনো কোশ্চেন?
স্যার এরপর আরেকটাতে কোশ্চেন আছে।
বলো। Before I move on, everyone else, এই ক্যালকুলেশনের স্টেপটা বুঝা গেছে কিনা? The important bit to understand over here is that object x is keeping the relevant amount of force it requires for its own acceleration and transferring the remaining force onto object y. এটুকু হচ্ছে basic idea.
স্যার নাম্বার 36।
আচ্ছা 36 টা দেখি। আচ্ছা এটা একটা ভালো কোশ্চেন, গুড পিক। মাঝখানে অ্যাকচুয়ালি আরো অনেকগুলো কোশ্চেন আছে যেগুলো আমি টিপিক্যালি ক্লাসে দেখাই। আচ্ছা আপাতত আগে রিকোয়েস্ট লিস্টটা করে নেই, তারপর তোমাদের দরকার অনুযায়ী আমি অন্য প্রবলেমগুলো দরকার হলে দেখাবো, কোনো সমস্যা নাই। কোশ্চেন নাম্বার 36 এর আইডিয়াটা বেশ চমৎকার। Let's have a look at this question. The question says the diagrams show two ways of hanging the same picture. The diagram shows two ways of hanging the same picture. So we have the same picture, important information. We have the same picture hanged by two pieces of in two different ways. So it says in both cases the string is attached to the same points on the picture and looped symmetrically over a nail in a wall. So looped symmetrically over a nail মানে হচ্ছে এই যে এখানে যে upward arrowটা দেওয়া আছে, এই upward arrowটা হচ্ছে just a force arrow. Actually the physical object that exists over here is the picture frame and the picture inside, and there is a loop of string that is going over a piece of nail which is stuck onto the wall, and it goes on like that. And for this figure it goes over like that. So basically on diagram 2 the string length is a bit longer, and on diagram 1 the string length is a bit smaller. That's pretty much the base thing that is happening over here. এখন কোশ্চেন হচ্ছে যে আচ্ছা the forces shown are those that act on the nail. In diagram 1 the string loop is shorter than in diagram 2. Which information about the magnitude of the forces is correct? To make sense of this question, this is the first part here to understand. Here these three forces are going to create equilibrium. Here these three forces are also going to create equilibrium because we want to have the object in stationary case. Now here's the deal. The resultant of T1 and T2 should be equal and opposite to R1. Now what you need to understand, if you try to think about it, in this case the forces that we have shown, I mean these three forces that we have shown, this is the force experienced by the nail. Try to understand this part. These three forces are experienced by the nail. The nail experiences two tensions in this direction and one reaction force upwards, so that the nail is actually stuck on the wall the reaction force is obtained from the friction force with the wall, and the T1 and T2 are the tension forces from the string of the photo picture. So they are producing equilibrium. What you need to understand that if we try to consider these tension forces T1 and T2, let's say not working on the nail, rather if we try to consider the forces working on the for the individual object, that is the picture would actually have a weight force working on itself which is equal on both sides. And what is also true, the sum of, I mean, when the nail is experiencing the T1 T2 like this, at these two connection points the tension forces are going to be that way. So আমি এই জিনিসটা মানে ঢালাভাবে বোঝানোর কারণ হচ্ছে so that you get a better understanding of for how vector diagrams work. This is an important bit for what I need to understand. So আমি একটা জিনিস খেয়াল করো, আমি যদি I'm going for diagram 1 to begin with. Diagram 2 তে পরে আসতেছি. If I draw the force diagram for the nail, this is how my force diagram for the nail should look like. We have the R1 over here, we have one T1 working this way and that T1 working this way. This is a force diagram for the nail. And if I want to draw the force diagram for the picture, that figure should look like this. I mean, in terms of position, if you have the if you consider all the positions, let's say the W works over here, one T1 works this way, the other T1 works that way. এই ফিগারটা বুঝছো কিনা পোলাপান দেখো, the picture is experiencing the pull in the upward direction. T1 and T2 কিন্তু পিকচারের জন্য downward direction না, নেইলের জন্য হচ্ছে downward direction, because the tension in the rope is gonna work in opposite direction for the two different ends at which the forces are working. So it's important that you do not mess up these two directions applicable for the picture. That's not how it works. Now in this case the forces are not working in the same point, so might as well not be a very good way to judge the figure, but for the sake of easier drawing, I can replace these two forces that are working on the same single point. So even if we consider the picture over here, let's say this is the center of gravity of the picture considered to be a single object or a particle per se. So it works downwards like this, one T1 force work that way, the other T1 force work that way. So this essentially mean that the vector sum of these two forces should be definitely equal to W. And the top figure essentially meant that the vector sum of these two forces should be definitely equal to R1. এই দুইটা জিনিস বোঝা যাচ্ছে কিনা? What I'm trying to get at, that this R1 must be equal to W. এই জিনিসটা logically understandable কিনা?
Yes sir, বুঝছি স্যার।
স্যার একটু আরেকবার বুঝাবেন স্যার কিভাবে R1 = W?
Because the nail is a stationary object and also the W is the picture is also a stationary object. So এখানে আমাদের জিনিসটা হচ্ছে the resultant sum of these two T1 forces, they are both T1, so I cannot differentiate them. So if I just try to write them, let's say T1 plus W should be equals to 0, or in other words I can write T1 plus T1 equals to minus W. এটা বুঝছো কিনা দেখো?
Yes sir.
Yes sir.
And এটা শুধু I should definitely use vector signs over here because I'm trying to show you in terms of vector equation. So এই দুটো T1 এর vector sum মিলে আমাদের minus W আসবে. If you have a look for the vector diagram relevant for the nail, এই কেসে আমি লিখতে পারি কি, আমি লিখতে পারি হচ্ছে T1 plus R1, all three of them are vector, should be equals to 0, which ultimately gives me what? T1 plus T1 vector, this is equals to minus R1. তার মানে ultimately কি আসলো, আমার এই জিনিসটা equal, because they are both equal to the vector sum of T1 and T1 obtained from two different figures, but T1 force are pretty much the same because they are working through the two ends of a string. So point that I'm trying to establish over here through all of this discussion by two different vector diagrams for applicable cases, that both of these R1 and R2 should be equals to weight of the picture. এই লজিকটা আগে বুঝছো কিনা দেখো, বাকি পার্টটুকু ইজিয়ার, এইটুকু অ্যাকসেপ্ট করাটা একটু ডিফিকাল্ট। দে আর দ্য সেম পিকচার, সো ভার্টিক্যাল ফোর্সটা দুই কেসেই ইকুয়াল হইতে হবে। ক্যান উই অ্যাপ্রিশিয়েট দিস মাচ ফার্স্ট? ঠিক আছে, সো if we do understand that, so we can logically deduct C or D of our possible choices. So A or B থেকে চুজ করতে এখন দেখতে হবে যে আমাদের কোন ফোর্সটা কিরকম হবে। এখন দেখো, I'm gonna try and draw some angles over here and try to go through some trigonometric distribution for these two forces. Zoomed in a little bit because I need more space. So let's say the angle that it produced with the horizontal is θ1. The angle that this one produces over here is θ1, and let's try and divide these forces one by one. Now I'm trying to divide over here for the red arrow forces, not the drawn arrow from the question, because I'm trying to divide the forces with respect to W. If you don't want to do it for W, you can also do it for from the nail point as well. So I mean, if I label the theta forces over here, I could actually show the forces over. I mean, drawing the thetas over here would mean I'm gonna try to divide this force. So the forces that is experienced by the picture. But alternately, I could also draw the θ1s and θ1s over here and over here, and I could also work with the T1 as well. Can be approached either way, however you feel comfortable, you can go for that. I'm showing you for these two theta angles. If you're interested, I might show you for the other way as well. So এখানে যেটা হবে, if I consider for this angle, I'm going to have a horizontal component of this T1 force. This is going to be T1 cos θ1, and on the vertical side, I'm going to have T1 sin θ1. The same thing can be said for this part as well. Towards left over here, I'm going to have T1 cos θ1. On the upward direction, I'm going to have T1 sin θ1. By virtue, these two cosine components are going to be equal to each other, and they are working opposite direction, so they will simply balance each other out. So the sum of these two parts, this and this, will be equal to W. In the same way, in the exact same way, if I consider the angle that exists for this second figure over here is θ2, and this part over here is θ2, so we can also consider that these horizontal components are going to balance each other out. The two upward components available from these 2 points are going to be equal to W. And W যেহেতু দুজনের জন্য সমান, so ultimately I can write this part. So I'm going to keep these two pictures in. What did I do? I think I messed up big time. No, I didn't. Acha, I might as well write the equations right over here. So for the first equation, I can write 2 T1 sin θ1 equals to W, and over here I can write 2 T2 sin θ2 equals to W. Both of them are equals to W because they are both equal to the vertical forces. So basically these two expressions should be equal. So I can also write that T1 sin θ1 equals to T2 sin θ2. এই পর্যন্ত বেসিক্যালি বোঝা গেছে কিনা? This is just by dividing the forces up. এখন আমাদেরকে লজিক্যালি জাজ করতে হবে যে θ1 আর θ2 এর ভ্যালুর কম্পারিজন অনুযায়ী T1 আর T2 এর মধ্যে কোনটা বড় হবে কোনটা ছোট হবে। So we are trying to, let's say, compare between T1 and T2. So have a look over here. As per the figure, θ1 is a smaller angle, ঠিক না? And θ2 is a bigger angle. The way I have labeled these angles over here, which essentially means that this is going to be a smaller ratio, this is going to be a bigger ratio. This is usually something that I actually do whenever I'm trying to solve problem. Draw bigger circles and smaller circles. If this is the case, so প্রোডাক্টের ভ্যালু সেম হওয়ার জন্য আমাদের T1 আর T2 এর মধ্যে বড় হইতে হবে কোনটা, ছোট হইতে হবে কোনটা? For the sin ratio, this is the scenario. Sin θ2 has a bigger value, sin θ1 has a smaller value. So between T1 and T2, which one should be bigger and which one should be smaller?
T1 should be bigger.
T1 should be definitely bigger, and 2T should be definitely smaller, so that the product would actually work out to be equal. So that basically gives my answer, which is C is the correct response. বুঝা গেছে?
Yes, sir. So B.
Sorry, B, my bad. হ্যাঁ, মানে lower left corner. হ্যাঁ, B is the correct response.
Yes.
So that's that.
আরেকটা কোশ্চেন আছে স্যার। স্যার আমি বলছি ব্যাক করে নিন স্যার। 3.3 নাম্বার 8।
Let's have a look. এই কোশ্চেনটাও একই মেকানিজমে সলভ করতে হয়। এখানে একটা জিনিস দেখো, নাম্বার 44 এ এই যে এখানে ম্যাস অফ দ্য পিকচার দেওয়া আছে 4.2 কেজি, আর এখানে আমাদের দুইটা ওয়্যার দেওয়া আছে ইকুয়াল অ্যাঙ্গেলে। সো হরিজন্টাল কম্পোনেন্ট গুলো ব্যালেন্স আউট করে, আলটিমেটলি এই টেনশনের ভ্যালু থেকে আমাদের ওই ভ্যালুটা একই প্রসিডিউর বের করতে আমি যে প্রসিডিউরটা এখন দেখাইলাম। So you just have to draw these two up. So 2t sine 25 equals to 4.2 into 9.81, and you solve that for that t value, you get that number. 3.3 এর কোনটা বলছো?
Number 8, 3.3, number 8.
Yes, good question. So let's have a look at this one. This is 3.3 question number 8, although it is 13 labeled over here, which is the worksheet actual question paper number. Two rigid rods xy and yz are fixed to a vertical wall at points x and y. A load of weight W is hung from the point Z. The load is not moving. Which diagram shows the forces acting at point Z? আচ্ছা, এইটা বুঝার উপায় কি? আমি একটা একটা করে জিনিস আলাপ করতেছি। Should I go for the pivot method or should I go for the composite body method? What would be easier for you to understand?
Sir, both, I think.
You don't know what I'm talking about.
That's
আচ্ছা,
true,
আমি
sir.
আমি আগে কম্পোজিট বডি মেথডটা আগে আলাপ করি, কারণ এটা আরেকটা কোশ্চেনের জন্য রিলেভেন্ট হয়। একটা জিনিস খেয়াল করো, খুব সিম্পল একটা জিনিস বোঝার চেষ্টা করো। মনে করো, লেটস সে we have a wall over here and from the wall there is a rectangular plank sticking out. So there is a rectangular plank that was built within the wall, or that was glued or bolted within the wall. So this is a rectangular plank. Okay, এই রেক্টাঙ্গুলার প্ল্যাঙ্কের এখানে মনে করো একটা কি ঝুলানো আছে। Let's say we have signs over here. Let's say we have the sign of 9 gag hanged over here. এখন how would this weight of this whole sign working downwards is going to cause deformation within this plank? How is this going to work?
Sir,
What
can
is-
you read the last line?
How this weight that is working on this end of the plank is going to cause deformation on this plank? How the deformation will happen? Now, one thing is obviously true, that because we have stuck up this plank within this is basically what we call in engineering term a cantilever, where a lever is supported by only at the planting end and there is no other supporting end, or like no rope or nothing is given. So this is one single piece of object, so just one single object. Essentially what is likely to happen because of the idea of deformation, because of the weight, this object is going to undergo a little bit of curving. So this object should bend a little bit like that. I'm showing you a whole lot more than usual so the next scenario, because of the way, I mean, if the plank was straight or perfectly horizontal without the existence of the load, whenever we're going to apply the load actually on the object, the plank might actually start to look a little bit like that. So it might actually bend a little bit, not become thinner. So disregard that fact. And let's say now this is the point where the sign is hanging by. So let's say we have the sign over here. So my point is, whenever we are having this kind of a curvature or arc, what actually happens? The way it works out is that the outer side experiences a tension force for which it actually bends like a curve. And so this outer part undergoes extension and the inner part undergoes compression. And the total object undergoes a composite scenario of deformation where you have both extension and compression within the object at the same time. This is the scenario that we call bending. Bending is slightly different than actual cases of single cases of extension or compression. For example, if I just put it this way, if you have a horizontal bar, let's say if you have a horizontal bar, if you apply tension force onto it, you can make it longer. If you apply compression forces onto it, you can make it shorter. But if you apply vertical forces onto it, let's say this is your horizontal bar, definitely supported by two ends by some other means, which I'm not showing in the figure. But if you now start to apply lateral load, so this was these two cases, the loads were applied axially. So if you this is the axis line of this thing, these two cases where the forces were applied along the axis. But if we apply some lateral load, or which is working like this, in that case the object is going to start to bend, and whenever the bend happens, the inside surface experiences compression and the outer surface experiences elongation. That's how objects behave. So it takes a little bit of curve. So this is the inside arc, which is smaller than the original length. This is the outside arc, which is bigger than the original length. এই পার্টটুকু বুঝা গেছে কিনা
Yes, sir.
আব্দুল্লাহ?
Yes, sir.
আচ্ছা, এটা দিয়ে বোঝানোর সহজ বিবরণ হচ্ছে যে now if you consider this same single image and if you try to just consider this whole thing xyz as per se, let's say a composite object, you should understand whenever the load is working over here, this upper part of the bar should be in a state of tension, and the lower part over here should be in a state of compression. So that's one way to judge this whole problem. There is another way to come to the same idea. That's just by looking at the figure for individual different lengths of the rods one at a time. Let me put it this way. Let's say আচ্ছা, জিনিসটা চিন্তা করো, মনে করো আমাদের এই সেটআপটা আছে. So we have this setup and we have both the wires x and y, we have both the rods xz and yz, and we can take away one of these rods as per our wish. If we want, we can move one of the rods out of the whole system. Try to understand. If we consider, let's say, mone koro, both of these two rods are hinged at this end, so they can actually rotate about the individual positions. Now, if I move the yz rod away, if I take the yz rod out of this scenario, so if we just take it away and then allow the load to work on this hinge point, what's going to happen? This load is going to cause this point to fall downwards.
Yes, sir.
And it's going to go by taking this exit length as a radius. What you need to ask yourself, how would that length yz is going to experience the change of length at that, for that deformation, for that change of orientation? Should the exit length become smaller, or should the exit length become longer? Sorry, should the yz length become smaller or longer? So what I'm trying to ask you, let me clear up the figure. If we remove yz and w load starts to pull down the z load like that, taking this point as a arc of radius, what should happen to the yz length? কমে যাবে, but এই কমে যাওয়ার ব্যাপারটা দেখতেছো কিনা? Can you see it?
Yes, sir.
It means, so that actually proves that whenever the yz rope or yz stock support was there, it was actually experiencing a compressive force. That's one way to judge it. Alternately, if you consider the second scenario, let me just erase all of these marks. Let's say in another case, let's say the scenario is over here with both the xz rod and yz rod both are here. If we now take the xz rod away, if we take this rod out and allow the whole system to rotate by, so now the whole system is going to rotate, taking the y point as our radius of arc. So this is going to undergo a rotation like that, where this would be your radius. If the z point falls around in a circle like this, what should happen to the xz length? Should it become smaller or should it become longer?
Longer.
Subsequent change should be longer, which means that whenever the whole system was in equilibrium, xz was in a state of extension, or it was under a state of tension force. এটা হচ্ছে জাজ করার আরেকটা উপায়. So if you try to visualize the whole system with one component working, the other one missing, and try to visualize what happens to the other component, then you can actually find out what kind of force do you have. এইটুক বুঝা গেছে কিনা clearly?
Yes, sir.
আচ্ছা, এখন আসো আমরা ফোর্সের ফিগার গুলাতে আসি। এই কোশ্চেনটা অ্যাকচুয়ালি সলভ করা প্র্যাকটিক্যালি খুব সহজ। আমি এই কোশ্চেনটা সলভ করার জন্য আমি যে এতগুলো কথাবার্তা বলছি, এতগুলো কথা তোমার না জানলেও কোনো সমস্যা নাই, তুমি তারপরে এই কোশ্চেনটা খুব ইজিলি সলভ করতে পারতা। কথাগুলো বলতেছি একটা কারণে, বোঝানোর জন্য। সেটা হচ্ছে যে now if we try to find out the forces working on the z point, try to have a look. I'm gonna have the figure one more time. Okay, so at the z point, one of the obvious force works is downward force, which is w, weight works downwards without a question. And now what you need to ask that what is the force exerted by the xz rod at the z point. Now try to understand, xz is within a state of tension, so the response of xz rod would be to pull from both sides. So let me put it this way: if you have an object, let's say a rectangular object, normal rectangular object, that you want to be in a state of tension, you have to pull on both sides, or you can keep one of the side fixed, pull on the other side, which basically apply force on both sides by equal amount. So this is what you call tension. If whenever we will exert a force on outer direction on the object by the property of elasticity, object's reaction would be to pull inward. ঠিক না?
Yes, sir.
So because xz is within a state of tension, so the force exerted on point z by the xz rod would be in this direction. So xz was about to be pulled, so xz will try to pull inwards. And or I can put it in another way, that the W load is causing the Z point to go further away. So the XZ rod is going to pull it from the Z towards left. It's going to try to pull it closer. In the same way, YZ is going to try to push it outwards because this was under the state of a compression. So এখন তুমি খুব ইজিলি ফোর্স গুলো নিয়ে কাজ করতে পারবা। So YZ এর ডিরেকশন হবে হচ্ছে আপওয়ার্ড রাইট, x direction হবে downward left, and w should be working downwards, and together you should have a cyclic diagram of forces that should give you zero resultant force. Cyclic diagram means whatever your diagram looks like, if you place all the forces one after another, your diagram should be a closed triangle where all the forces are working in the same sequence. So not like this, because here the forces are not working in the same sequence. So if you for a case where you have an equilibrium, which I showed you in the earlier class for the Lamis theorem, আজকে এটা মনে হয় লামিস থিওরেমের প্রুফ দেখানোর কথা। লামিস থিওরেমের প্রুফ তোমাদের ক্লাস দেখাইছি না?
ইয়েস স্যার।
লেকচার আপলোড করছি?
জি জানি না স্যার।
মনে হয় কই নাই। আচ্ছা আমি দেখবো জুমের
করেছেন স্যার।
আচ্ছা জুমের ফলোয়ার। আচ্ছা ঠিক আছে, থ্যাংক ইউ। So the idea is that if you have multiple forces producing equilibrium on an object, and then if we apply if we draw a vector diagram with all the forces with appropriate scale and direction, place all the forces one after another, you're going to end up with a closed triangle, closed polygon. In this case we have three forces, so we should have a triangle, but all the forces should be in the same sequence. All the forces producing zero resultant, so let's say force of W plus force that works along xz plus force that y along yz, সবগুলা মিলে যদি জিরো হয়, দ্যাটস দ্য হোল পয়েন্ট অফ দ্য ইকুইলিব্রিয়াম। সেই কেসে আমরা যে ভেক্টর ট্রায়াঙ্গেল আঁকি না কেন, যেরকমই ভেক্টর ট্রায়াঙ্গেল আঁকি কেন, অ্যাপ্রোপ্রিয়েট ওরিয়েন্টেশন এবং স্কেলে আঁকলে সবগুলার সাইক্লিক অর্ডারের সেম থাকবে। সাইক্লিক অর্ডার মানে বুঝতেছো? all of the arrows should be giving you in the same direction. Exactly. So this logic that I just told you is good enough to solve this problem, because if you look closely in all of these figures, you will only find one figure where all the forces are properly or arranged in that manner. If you have a look over here, A is your correct answer for this thing, because you can see that this is the only figure where these three forces are in a continuous cyclic order. B is not. You can see that these forces are seen to start from this point. So in this case xz and yz are in a order, but w is not. So B তোমার correct answer হবে না। C তে যদি দেখো w আর yz is in order, but xz is not. So তোমার C ও হবে না। D তো একই সমস্যা। In this case xz and w are in order, but yz is not. So just by knowing that the forces should give you a closed polygon working in the same orientation, এটুকু জানলে এই কোশ্চেন ইজিলি সলভ করা যায়। আমি এত হাউকাউ করে টেনশন এবং কম্প্রেশনের কনসেপ্টটা বুঝাইলাম যাতে করে তোমাদের পরবর্তীতে এই ধরনের প্রবলেমগুলো সলভ করতে প্রবলেম না হয়। বাট এই ডিসকাশনটুকু বুঝা গেছে কিনা?
ইয়েস স্যার।
ক্লিয়ার হয়েছে?
ইয়েস স্যার।
আচ্ছা, তারপর
আর নাই স্যার।
আচ্ছা, এই কোশ্চেনটা মোরলেস সিমিলার টাইপের কোশ্চেন। এখানেও একই জিনিসই করতে হয়, দেখতে হয় যে অ্যাকচুয়ালি আমাদের অ্যালাইনমেন্ট অনুযায়ী কোন ফিগারটাতে তিনটা ফোর্স একই অ্যালাইনমেন্টে আছে।
স্যার
বলো
স্যার, একটু 19 নম্বরে যেতে পারবেন, এই যে 3.3 তে।
ইয়েস
স্যার পি মাইনাস কিউ, তো মাইনাস কিউ কি আমি আলাদা করে নিব, যে কিউ ডাইরেকশনটা অপোজিট ধরবো না?
পি এর শেষ মাথায় এইদিকে একটা ভেক্টর রাখবা, সো
Yes, sir.
মাইনাস কিউ হবে ওইদিকে, সো সি ইজ দ্য কারেক্ট রেসপন্স অবভিয়াসলি আই থিংক।
আর স্যার এই যে আগের ইকুয়েশনে স্যার, মানে আগের কোশ্চেন নাম্বার 18 স্যার, এখানে ভি ইকুয়ালস টু ইউ প্লাস 80 এরকম কয়টা দেখছিলাম ভেলোসিটি মানে ভেক্টরস এর, মানে একটা যদি ভি ইউ থাকে একটা 80, দুইটা অ্যাড করে ভি পাবো।
বাবা এই যে
হ্যাঁ হ্যাঁ স্যার, এই যে এটা স্যার, এরকম কি আর কোনো ইকুয়েশন আছে লাইক যেগুলা করে বুঝবো?
অনেক ইকুয়েশন আছে। তুমি যতগুলো ভেক্টর মানে for all the physics equations where you come across a vector quantity that is involved and there is some sort of a plus or minus sign, you can apply the idea of vector geometry. For example, এইটা ছিল হচ্ছে আমাদের ফার্স্ট ইকুয়েশন অফ মোশন, where final velocity equals to initial velocity plus acceleration into time, which means এই দুটাকে ভেক্টর সাম করলে এটা পাওয়া যাবে। If you consider the third equation, displacement equals to ut plus half at squared, same stuff. This is a vector quantity, this is a vector quantity. If you vector sum this up, you're gonna get this, which happens to be not applicable for the fourth equation, because in the fourth equation we actually square up everything.
Yes sir.
So ultimately this becomes a scalar quantity. The v is a vector quantity, but once you square this up, it is actually a dot multiplication or scalar multiplication within itself. So v square becomes a scalar quantity. So a equation er jonno ar vector multiplication বা vector sum applicable. This is going to be just a numerical value addition. But these two equations can be very well represented with actual vector triangle rule or vector geometry parallelogram rule.
Yes sir.
এরকম আরো ফিগার যদি তুমি চিন্তা করো, ফর এক্সাম্পল what other equations do we have where we have a vector quantity with a plus sign? Do we have any such thing for forces? mgh
Sir, can you actually explain number 7 a bit? মানে স্যার আনসারটা কিভাবে পাবো স্যার বুঝতে পারছি না স্যার।
একটু দাঁড়াও ইউসুফ, এক মিনিট বলতেছি।
ওকে স্যার।
I equals to NAVQ. I can think of other vector equations which have a plus sign inside. There are a lot of vector equations which looks like the equation F equals to ma. এই টাইপের equations হাজার আছে. For example, you have electric field strength, you have magnetic field strength, you have the a lot of quantities are there which are given by the multiplication factor. But vector equations like these which have vector quantities involved, and there is also a meaningful plus sign in between, I think there are quite few in number. I can only think of these two for the time being, but if something else shows up, eventually I should be able to recall this discussion. Okay, Yusuf, go ahead. কি বলতেছিলা?
স্যার নাম্বার 7টা কিভাবে স্যার করব স্যার, এটা একটু দেখে দিবেন স্যার।
Sure. Polman, I have a poor update for you. আমার গ্রাফিক্স কার্ড নষ্ট হয়ে গেছে।
স্যার শুনতে পারিনি স্যার।
আমার গ্রাফিক্স কার্ড নষ্ট হয়ে গেছে।
Oh sorry.
I'm not playing games. আমি জাস্ট এখন পুরান ভিডিও দেখে সময় পাস করতেছি।
তার মানে আপনি এখন ডাউনলোড করেছেন, খেলতে পারবেন না?
না, আমার পিসিতে কিছু পুরান গেম আছে। ফর এক্সাম্পল, if you have a look over here, I have the Red Alert 2, I have the Generals, and I have the Zero Hour, Commando.
You recommend Red Alert?
Commandos 2. I have the Heroes Revenge online version. Over here, I have the chicken game. For those who know what game this is, you know how much fun it can be. Yes, I have Unreal Tournament. I can play these things with my default graphics card, which is really something that I'm not very happy with. For example, the graphics card that I have right now does not even show up here. It's so weak. কই জানি দেখে graphics card? এই যে, this is my graphics card. Intel R HD graphics 530. So yeah. So কষ্টে
Sir, are
আছি।
you planning to play PUBG?
No, I'm not planning to play PUBG. Why did you see PUBG? There is no PUBG in my PC.
No, sir. But
স্যার
হ্যাঁ বলো।
স্যার আপনি তো চিটাগাং স্যার, ল্যাব যখন শুরু হবে তখন কেমনে, মানে যদি খুলে দেয় সব?
ওয়েল, যদি তোমরা ফিজিক্যালি ক্লাস করার জন্য মুভ আউট করতে পারো, যদি খুলে দেয় তাহলে আমি পট করে ঢাকা চলে আসবো। আমার বাক্স প্যাটার্নে ঢাকা আসা তো খুব ডিফিকাল্ট কিছু না। I just have to book a large seat arrangement, that's it, nothing else.
ওকে স্যার।
মানে আমার চিটাং থেকে ঢাকায় মুভ করার জন্য আমার কি কি আনা লাগবে সেটা বলতেছে। আমার টোটাল পিসি ইকুইপমেন্ট, কিবোর্ড, মাউস, আমার রাইট প্যাড, আমার মনিটর, আমার ইউপিএস, আমার মাল্টিপ্লাগ, আমার সিপিইউ, এই ঠিক আছে।
sir, UPS?
Yeah, I have a UPS here. এখানে মাঝে মাঝে কারেন্ট ডিসরাপশন করে। এইটা এটুকু হচ্ছে আমার পিসি ইকুইপমেন্ট। আর হচ্ছে আমার একটা লাগেজ যেখানে আমার জামা কাপড় থাকবে। আর ভাত খাওয়ার জন্য তো টাকা আছে, হোটেলে গেলে ভাত খাওয়া যায়। ভাত খাওয়ার জন্য হাড়ি পাতিল আনার দরকার নেই। আচ্ছা, এই ফিগার, হ্যাঁ
বিজনেস পার্সন বেন না?
আমি বিজনেস পার্স মনে হয়, যদি আমাকে মানে শর্ট মানে খুব শর্ট নোটিস যদি ঢাকায় আসতে হয় তাহলে আমি বিজনেস পার্স নিয়ে আসবো না। মামুনের খাটে শুয়ে চালা দিব অ্যাটলিস্ট ফর কাপল অফ ডেজ। ইভেন্চুয়ালি যদি আমার পার্মানেন্ট সেটআপ করতে হয় তাহলে আমার বিছনাপাতি পার্স অলরেডি তো ঢাকায় আছে, সেগুলো বিছায় নিয়ে ঘুমানো যাবে। আচ্ছা, এইটা না, আমি তো এই কোশ্চেনটা কপি করতে চাইছিলাম, এটা কপি হয় নাই। আচ্ছা ইউসুফ, তুমি এই কোশ্চেনটা সলিউশনটা খুব সিম্পল। সেটা হচ্ছে এখানে একটা জিনিস দেখো, কোশ্চেনে বলছে হচ্ছে an object has initial velocity u, it is not subject to a constant force, it is subject to a constant force f for t seconds causing a constant acceleration a, the force is not in the same direction as the initial velocity, তার মানে u আর a are not in the same direction, a vector diagram is drawn to find out the final velocity v, what is the length of the side x for the vector diagram? So it's very simple, একটা জিনিস দেখো, এটুকু হচ্ছে u, এটুকু হচ্ছে v, these are two both represent as vector quantities, this is হচ্ছে x, and তুমি এটা যদি দেখো, if you look at this vector diagram, এই দুইটার সাম মিলে এই রেজাল্টেন্ট দিতেছে। তার মানে কি u plus x equals to v, where all three of them are vector quantities, and তুমি চিন্তা করো যে এই x কোয়ান্টিটি কি হইতে পারে,
এটি
বুঝা গেছে?
ইয়েস স্যার।
Okay, sir.
নো বিগ ডিল, হইতে পারে। ডায়াগ্রাম গুলো এভাবে দেওয়ার এইমটাই হচ্ছে তোমাদের আন্ডারস্ট্যান্ডিং গুলো চেক করা, যে তোমরা আসলে জিনিসগুলা টু ইটস কোর বুঝো কিনা বা অ্যাকচুয়ালি কতটুকু ভালো বুঝো। আচ্ছা, আমি আরো কিছু কোশ্চেন পিক আপ করি যাতে ডিসকাশন করা যায়। ফর এক্সাম্পল, ইফ ইউ হ্যাভ এ লুক এট দিস কোশ্চেন নাম্বার 4, have a look at this question. It's the same type of a question, but all that you need to understand for this question is that all the three forces should be in a cyclic order. That's pretty much it, that all you have to judge for. Have a look. The diagram shows a sign of weight 20 newtons suspended from a pole attached to a wall. The pole is kept in equilibrium by a wire attached at point x.
স্যার আপনি কি কিছু বলছেন?
হ্যাঁ,
স্যার আপনার মনে হচ্ছে কথা কেটে আসছে স্যার।
না কথা কেটে আসতেছে না, আমার মনিটরের কালার কন্ট্রাস্টটা আনকমফোর্টেবল লাগতেছিল। এই মাত্র আবিষ্কার করলাম যে এতক্ষণ এটা মানে ডিফারেন্ট মোডে ছিল, ডিসপ্লে মোডটা ডিফারেন্ট ছিল, ওই জন্য আমার মানে একটু খটকা লাগতেছিল। এখন ঠিক আছে। সো blah 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 blah, it is kept in equilibrium by whatever attached at point x of the pole. The force exerted by the pole at point x is F, and the tension in the wire is 40 newton, which diagram represents the three forces acting at point x. So এই x পয়েন্টে তিনটা ফোর্স কি কাজ করবে? Obviously একটা ফোর্স কাজ করবে হচ্ছে ওয়্যারের অ্যালাইনমেন্টে, একটা ফোর্স কাজ করবে হচ্ছে পোলের অ্যালাইনমেন্টে, একটা ফোর্স কাজ করবে হচ্ছে সাইনের অ্যালাইনমেন্টে। Now essentially what you should be able to understand that this direction, I mean one force that is, let me just copy this one. what should be readily understandable for this figure is that the weight of the sign should definitely work vertically downwards right here. The tension of the wire should work at this point, working upward left. And if you want to balance these two forces, which is you must have a reaction force which should work up in the outward direction, so that you can have a zero resultant force out of all of these three forces. So এই তিনটা ফোর্স মিলে eventually কোনটা কারেন্ট আসবে, eventually যদি তুমি এই জাজমেন্টটা নাও করতে, if you don't even want to go through this consideration, just have a look at these three options and try to figure out the correct answer. You should understand that the wire force should be in the parallel direction of the wire, and the F force, which is defined as the exerted by the pole, should be horizontal. So CRD প্রথমেই বাদ, because CRD তে F force কে horizontal দেখানোই হয় নাই, so CRD বাদ. And between A and B একটা ফিগারই আছে যেখানে আমাদের সবগুলা ফোর্স পারফেক্টলি সাইক্লিক অর্ডারে দেওয়া আছে. Have a look at this figure. Here the forces are in cyclic order, but this figure is not. So obviously B is the correct response, which basically shows all the forces in the correct orientation as well. So এই টাইপের কোশ্চেনগুলো সলভ করা প্র্যাকটিক্যালি, you just have to look at the question properly, and that would be a good way to go for it. এখানে আরেকটা কোশ্চেন আছে, হচ্ছে এইটা. এই কোশ্চেন আমি একটু আলাপ করি. এই কোশ্চেন একটা ভালো একটা কোশ্চেন, স্টুডেন্টরা অনেক সময় কোশ্চেনটাতে ঝামেলা হয়. Why can't I select this? এই কোশ্চেনটা দেখো, this is 29 of what segment? 3.2. তোমরা ওয়ার্কশিটের 3.2 এর কোশ্চেন 29টা উল্টাইতে পারো, or you can still keep looking at the screen. Have a look at this question. The diagram shows two pulley wheels connected by a belt. Wheel Q is driven by a motor and rotates clockwise at a constant rate. Wheel Q puts tension in the top portion of the belt, which in turn drives the wheel P. The lower portion of the belt is slack and has no tension. The weight of the belt and frictional forces are negligible. The diameter of P is 150 millimeter. The diameter of Q is 100 millimeter. The torque applied to Q is 3.0 Newton meter. What is the tension in the belt and torque on wheel P? একটা একটা করে জিনিস বুঝো. Q is driven by a motor and rotates clockwise. তার মানে এইটা clockwise ঘুরতেছে at a constant rate. This puts some tension in the top portion of the belt, which means this part of the belt is under some tension. The lower portion of the belt is slack and has no tension. তার মানে এই পার্টে কোনো রকম ফোর্স নাই. তার মানে এদের মধ্যে যা ফোর্স ট্রান্সফার হচ্ছে বা মোমেন্ট ট্রান্সফার হচ্ছে or energy transfer হচ্ছে, however you put it, this all is happening because of the top portion. The lower portion is perfectly slack. The weight of the belt and the frictional forces are negligible. The diameter of P is 150 millimeter. So এইটুকুর diameter হচ্ছে 150. So I'm gonna label the radius over here. So might as well get rid of the whole line. The radius of this thing is 75 millimeter. The radius of this thing, if you wonder why am I going for labeling the radius, because that's what we're going to need to do the calculation. Perpendicular distance of the force from the pivot point. You have to understand that this belt is going around the circle. So this is your pivot point for wheel P. This is the perpendicular distance, which is basically the radius of the wheel. This Q is over here. So this is the perpendicular distance, which is the radius. So you don't need the whole diameter. This is one of the primary mistake many students do, although sometimes they also come up with the same correct answer because the diameters can actually work out on both sides equally. Question the torque applied to the Q is 3.0 Newton meter. What is the tension in the belt? So what you should understand that the tension should be equal on both sides, but the torque might be different. So we can write that this tension force multiplied by so tension T for Q should be equals to 3.0 divided by 0.50 divided by 1000 করলে কত আসে? 0.05. এটা হচ্ছে tension of the Q part of the belt, which is equals to 60 Newton. A 60 Newton tension on the belt should be also equal to tension for P. So এই পয়েন্টে আমাদের টেনশনের ভ্যালু পারফেক্টলি 60 নিউটনই হবে। এই 60 নিউটনের জন্য টর্ক কতটুকু হবে সেটা ক্যালকুলেট করা হবে। So torque on, so this is tau, I'm trying to write tau over here, which is a bit of a curved tail. So torque of wheel P will be given by 60 multiplied by 0.075, which gives you how much? 4.5 Newton meter. So D is the correct response. বলুন দেখো ক্যালকুলেশন
বললেন
বুঝিনি, বলো।
টিকিউটার ক্যালকুলেশনটা বুঝিনি।
TQ হচ্ছে considering that the tension, the force that is working on the Q wheel is TQ, and the tension force that is working on the wheel part of P is TP, which is basically equals to the core tension. I'm just writing them for two different numbers because I'm going to work the math with two different values of moment. মানে দুটো ডিফারেন্ট হুইলের জন্য আমি টেনশনটাকে দুটো আলাদা নাম দিছি যাতে করে ম্যাথটা করা ইজিয়ার হয়, বাট প্র্যাকটিক্যালি তাদের ভ্যালু হচ্ছে সেম। বুঝছো কি বলছি?
জি স্যার।
আচ্ছা ঠিক আছে, তোমরা এমসিকিউ পেপারটা আরো ট্রাই করো। তোমাদের সাথে টুইসডে ক্লাস আছে, টুইসডে আমি তোমাদের পুরো এমসিকিউ পেপারটাই হোমওয়ার্ক দিলাম। ট্রাই অ্যাজ মাচ অ্যাজ ইউ ক্যান। আর আফটার স্টাডিতে কোনো প্রবলেম আসলে সেটা আমাকে দেখাইতে পারো, কোনো সমস্যা নাই। রিসেন্ট ইয়ার্সের কোশ্চেন পেপারগুলো ট্রাই করতে পারো, কারণ আমার বাসায় খুব রিসেন্ট ইয়ারের পেপার কোশ্চেনগুলো নাই, ইফ ইউ ক্যান ম্যানেজ টাইম। আর অ্যাজ ফার অ্যাজ আই নো তোমাদের কারোরই রেজাল্টে খুব বড় সড়ো কোনো ডিজাস্টার হয় নাই, ফর হুইচ আই এম ভেরি হ্যাপি ফর ইউ। অ্যান্ড বিকজ additionally because actual পরীক্ষা হয় নাই, I kind of find this happiness not so intriguing, but I'm still happy for all of you. I mean, you kids did great results, so congratulations, heartfelt congratulations from all of to all
Thank
of
you,
you.
sir.
তোমরা পরিশ্রম করছো,
Yes,
কষ্ট
sir.
করছো। I mean, যদিও অ্যাকচুয়াল পরীক্ষা হয় নাই, but the truth be told, coping with the whole COVID situation, I mean, is on its own pretty difficult take through, which you have to do every day. Living at home, continuously getting feedback. I'm not gonna say badgering, I'm gonna say feedback from your environment, surrounding people. I'm not gonna say people's name, but you know what I'm talking about. So in some cases this can be really good for you, in some cases it can be exhilarating, and in some cases it can be pretty bad, repetitive experience. But irrespective, you are still stuck within the four walls of your house, and having a sane, productive mind can be difficult at times. I personally understand that. I superbly appreciate that you guys are still holding strong and trying to cope through this. So my congratulations to you for your everyday struggle. Way more strongly congratulations compared to your results. I mean, compared to what you're doing every day to pass through the COVID situation, almost amounts to nothing compared to your O-levels result. Forget about that.
Sir,
Bolo.
can I ask you one thing?
Yes.
Sir, I am actually not able to speed up with the problems.
আচ্ছা, আমি লেকচারটা ক্লোজ করি, তারপর থিওরিটিক্যাল পাওয়ার নিয়ে আলাপ করতেছি। So the class is officially over. For those who want to leave, you can actually leave.